Hello, this is Brian Aslin, and today I'm going to be doing some math homework for my class. It's going to consist of 3 questions. The first question is: a small business has monthly expenses of 43,000, needs to cut those expenses by at least 15%. If the business is successful, what will be the new monthly income? Is the business cuts its monthly expense to 35,000? Is it a success? So first, let's work on that particular question. Expenses are 43,000. They need to cut that by 15%. To do that, I'm going to figure out what 10% of 43,000 is and what 5% of 43,000 . And then I'm going to add that %. So 10% of 43,000, we just move the decimal over, 4,300, and to get, so that's equal, so 4,300 equals 10%, and 5%. So to figure out 5%, we're going to take 4,300, we're going to divide it in 2. So we know that's 2, 5, 2, 1, so 2, we have 3 down, so we know 2. Then we're going to have a 10, so we're 5, 10, 0, 0. So 5% equals 2,150. Now we're going to add those up, and we get 6,450. Now we're going to subtract to figure out A, if the business is successful, what will the new expenses be? We'll need to subtract 6,450 from 43,000. So we're going to go 43,000 minus 6,450. And so 0, 10, no, that's going to be 50, 10 minus 4, 6, 6. So when we subtract 4,650 from 43,000, we get 36,650 is 15% less. So their new monthly income should be 3,650. So let's figure that out on a calculator in case I got my mathematics wrong. So we have 43,000 minus 15% equals, we have exactly the same number, 3,650, 36650. And so the answer to A is if the business is successful, the new monthly expenses will be $36,650. Now, the second part of the question is if they cut it to $35,000, is it a success? Well, we know $35,000 is less than $36,650, so we believe the answer to B is yes, is a success. Now it's time for the second question. In the second question, we have last year Fred spent $15,000 on a guitar, and Wilma spent $1,200. So $1,500 on guitar, and Wilma spent $1,200 on skiing. Fred spent what percentage more than Wilma? So to do this, we need to figure out a formula. And the formula to figure this out is X, which we're going to say is Fred, minus Y, which is Wilma, divided by Wilma equals our answer of what percent more. So what we're going to do is we're going to take 1,500 minus 1,200. That equals 300. So 300 by 1,200. Well, from our video last week, we do fractions, and we know that 3 can go into 12. So 3 times 4 equals 12. And then if we add the 100, so we know that this is a fraction of 3/4, which is 25% more. So Fred spent 25% more than Wilma using my math. Now let's figure out the hardest part of that on a calculator. Is 300 divided by 1,200 equals 0.25. And if we multiply the 0.25 by 100, then we get, once again, the 25%. Time for the final question. The final question is Barney has a 0% tolerance policy drug use at his company he owns. Therefore, he requires that his employees submit to a random drug test. He uses a test that is advertised as the test is equals 95% accurate. So when Wilma tests positive for drug use, he immediately fires her off on the claim that is the test is 90 means that 95% of the people have the condition test positive for the condition. Barney's decision to make this is based on the assumption that the two claims, and here's the two claims: 95% of people who use drugs test positive. And so we know that there's that 5% of people who use drugs who don't who are not positive. And now and this is of the people who use drugs. Now, the second claim is 95% of the people who test positive use drugs. Well, here's how these two claims are not really equivalent, because 95% of the people who test positive, well, it's not really the same thing, so they're not equivalent. And the reason why is because these are two different things. One is the people who test positive, and the other is the people who use drugs. So we know there's that extra 5% who use drugs who don't test positive, and then there's that you're really taking two different samples of people here, because in order to figure out, you're now working with 95% of the people, and you're trying to figure out, well, if 95% of those people test positive, so you're trying to figure out 95% of 95%, which is going to be not equal to 95% of 100. So of the people who use drugs, well, 100% of them use drugs. Of the people who test positive, well, there's that 5% who don't. So that's why these two claims are not comparable.